In the last lesson, we looked at layers of the Earth and evidence for plate motion. In this lesson, we will continue looking at plate motion and the different types of boundaries between the plates. These top two diagrams are both illustrating something called magnetic striping evidence. And this is evidence that supports the theory that plates are moving, and specifically that plates are moving outwards from each other at this specific type of boundary. Magnetic striping patterns in the Slifa rock are similar on both sides, and I'll show you what that means. So similar on both sides of an oceanic ridge. This here is an ocean ridge, and it's something that forms when you have two plates that are moving away from each other. So that creates a gap, it creates a crack, and magma can rise up and fill in that crack. And when that happens, that magma, it's liquid, but it's going to solidify when it reaches the surface and it cools. And that magma contains iron filings. And these little pieces of iron are all going to orientate themselves pointing towards magnetic north. So they're going to cool on either side of the ridge and all point towards the north. Some time ago, there must have been another spreading apart of the plates. And at that time, the magnetic north would have been somewhere else, because magnetic north is moving. So at that time, all of the iron filings would orientate towards wherever that north is. And so on and so on and so on. So you end up getting this mirror image on either side of this oceanic ridge, the point where the plates are separating. Because we can see this, because we have these mirror images, it indicates that new ocean floor is being created at the ridge. This next image here is showing a map of Earth's tectonic plates. And this brings us to a discussion of the theory of plate tectonics. The theory of plate tectonics has two big ideas. It says, one, that the Earth is divided into plates, and two, that these plates are constantly moving. You're going to be able to need to look at a map like this and recognize the different symbols that you see. So I have another one here. It's very similar. It shows a bunch of the different plates, and in between these plates there's going to be boundaries. And those boundaries have different symbols. You can see that some of them, like here, have triangles along the boundary. Sometimes a boundary is two lines separated by a gap, and sometimes a boundary is just one solid line. Three different types of symbols for three different types of boundaries. We're going to look at each of those boundaries in turn and what they mean. The theory of plate tectonics says that, let's get my pen going again, the lithosphere is divided into 12 plates. "12 large plates and about 20 smaller ones. And these plates are floating on the asthenosphere. Three different types of boundaries. First one is when they're moving away from each other, and this is called a divergent boundary. We can look at an animation of what a divergent boundary would look like, what would be happening. If I can push play here, so looking just at these bottom two screens, this is going to show the divergent boundaries moving away. And you can see that as these plates are separating, magma is able to come in, rise up, and fill in the gap. So the two plates are moving away, magma is rising in and filling in the gap. At divergent boundaries, because you're getting a separating of the plates, if this were to happen on land, you would get valleys and rifts. And if this were to happen underwater, you get something called a mid-ocean ridge. And a mid-ocean ridge is actually an undersea mountain range. So if we look back up to this other diagram, all along here, this is a divergent boundary, and we have mid-ocean ridge all along that. So it's an undersea mountain range. And that's because the magma rises up and fills in that crack and rises up above the level of the seafloor. Second type of boundary is when two plates are moving towards each other, and this is called a convergent boundary. Three different types of convergent boundary depending on what's happening. This can be oceanic-oceanic, if you have two oceanic plates converging. It can be oceanic-continental, if you have an oceanic plate converging with a continental plate. And of course, it can be continental-continental. To look at an animation of a convergent boundary would be this one here in the top right. You can see this oceanic plate is moving underneath the continental plate. So in this case, it's oceanic continental. And to show that again, as this is moving underneath, this magma is going to melt. So the crust here is going to melt, and that forms actually a chain of volcanoes all along the boundary. So different features depending on what type of convergent boundary you have. When you have oceanic, you get islands. When you have oceanic continental, you get ocean trenches and island chains. And you also get inland volcanoes. And at continental, you get inland mountain ranges. Last type of boundary we're going to move at is when the plates move past each other in opposite directions. And this is called a transform boundary. At transform boundaries, we get shallow earthquakes. And we get something called strike-slip faults. Going back to our animations, we can see an animation of a transform boundary. So that would be this one here. You can see the two plates are moving past each other in opposite directions. And I'm also going to show you an image, if I have it here. And this is showing these stripes used to be all lined up and straight, and then these plates are moving, and so the stripes are being pulled, they're being separated from each other. So you often get geological features like this being separated from each other at a transform fault. That concludes our notes on Chapter 17. We are going to start reviewing this chapter, and you will be having a checkpoint coming up very shortly.